Hello, we are Group 28 from CE 371. My name is Amid Musa Muhammad.
And I'm Steve Dowd, and
Reggie Penning is holding the camera. We're going to go straight to the point right now, so let's do the problem. We're doing problem 11.9 from the textbook using the slope deflection method. Now, here's the beam that we have, L-shaped, and we have a load on top, 2K. Looking at the back of the book, there's an equation. It tells you, it states that there's an external moment, PL over 8 on both sides. The dimension of this beam is 12 feet, 6 feet, and 8 feet, just to make sure. We're drawing a forced body diagram. We separate it into 3 parts, just to make it more clear. Now, segment BC and BA, and then we have the hinge here. Then we draw our internal moments, MBA here and MBC, and the external ones as well. And using this sign convention, we assume that MCB is equal to MBA. Now moving on, to use the matrix form that we learned in class with the VI, MI, VJ, MJ, we're only going to use the M's just for this problem. So, as you see, we have no deflection in our beam, therefore the deflection at I is going to be 0, deflection at J is going to be 0 as well. So all we're going to use is this moment, so negative 4 over L and 2 over L times EI, as well as these. Now, just in order to make it easier, I just labeled them on top, so it's easier to multiply. For span AB, well, it's going to have delta A, delta B, theta B. So for span BC, it's going to start out with delta B, theta B, delta C, and theta C. Now, going into our equations from the matrix, the moment AB is going to equal to negative 4 EI, as you see here, because we're starting at A over L, and then negative 2 EI theta B, so negative 2. And we're doing the same thing for MBA, but we're starting here, since it's B. We're going to have 2 over L EI, and have 4 over L, as you see. And for span BC, we're going to do the same thing, but we're going to label B as I, and we're going to label C as J. And using that, negative 4 over L, theta A, and negative, wait, why do I have theta? This should be B. Anyway, and 2 theta C, and then we have theta B and theta C. And we add the external moments to this span, since there's a point load acting on the span, on the beam. And then we have 3 unknowns, and we have 5 equations. And we're going to put them all together. Equation 1, 2, 3, 4, and 5. And we solve for theta B. And then from theta B, you can get theta C and theta A. Well, when I solved it, we got theta B to equal 11.604 over EI. And then plugging into the equations that are asked to find, MBC is equal to negative 2.901 kip feet, and MBA is equal to 2.901 kip feet.